Good evening to Madam Puan Norhayati. Today, I and my group member we are going to present our presentation about half wave rectifier and its component working principle and performance compared to a full wave rectifier. So before we enter our slide, I would like to introduce myself, Tarvan, and my team member Vimal and Naveen.
Okay. So let's go to the second slide, which is main component. Here are the to build a half wave decipher, we need a few key components such as AC power source, a diode to allow current flow in one direction, and also a load resistor to measure the output voltage. Lastly, transformers can also be added to step the voltage up or down. Okay. For the third slide which is circuit connection steps, here are the steps to build a circuit, which is firstly the the are the steps to build the circuit is that we should connect the AC input to the diode in the series and then place a load resistor after the diode. This setup allows us to absorb rectified voltage across the resistor.
So okay, now we are going to see the diode function in the rectification. So basically the diode is the heart of the rectifier and it allows the current to pass only during the positive half of the AC cycle. So during the negative half, the diode blocks the current effectively and chopping off half of the waveform.
So now I'm going to talk about output versus input waveform. So here you can see the difference in waveforms. The original AC input is a full sine wave, while the rectified output only has positive half cycle. That is why it's called a half wave rectifier. So now the pros and cons. The advantage, it is simple and low cost, whereas the disadvantage is low efficiency.
Okay, so Tarvan,
Yes,
I got a question for you. So
yeah, sure.
why, why should you use a half wave over a full wave?
So in my opinion, a half wave rectifier is used when simplicity, low cost, and minimal component are more important than efficiency. It requires only one a diode, making the circuit easy to design and inexpensive to build, while it provides low efficiency and a higher ripple output compared to a full wave rectifier. It is the deal for low power application like signal detection, battery charging, or learning purpose where high performance isn't necessary.
Okay, Tarvan, thank you.
By the way, I have a question for you, Naveen.
Oh yeah.
So, what happens if we remove the diode?
So basically, if the diode is removed, the circuit will no longer perform rectification. So when the AC input will pass directly through the output without being converted to DC. So this means the load will receive an alternating current instead of pulsating DC and defeating the entire purpose of the rectifier. Additionally, it could potentially damage components that are designed to operate only with DC voltage. So yeah,
Oh, that's great.
Okay, for the conclusion, thanks for watching this presentation. I hope you understand more about how wave decisive works and more explanation about it. We give a better explanation to you. That's all from us. Thank you.
yeah.
Thank you.